Okay, well you guys, I'm at the district or at the league track meet setting it all up, so hopefully you guys are in good hands. I think you have a highly capable substitute today who actually knows how to do math, so hallelujah, you guys are in good hands. So we're doing trig identities, which I really like and a lot of kids really struggle, but with a little luck we'll go through it slowly and you guys will get it. So if you did your reading, you should have all of these identities: cosecant, 1 over sine, cotangent, 1 over tangent, but there's another identity for cotangent, and that's cosine over sine. Okay, and that's an important one to have. Secant's 1 over cosine, but then I highlighted this one because we'll use this one a lot, and that's tangent of theta is equal to sine over cosine. Hopefully you have those written down in your notes. And I changed the x to thetas because I like theta better for the angle. Even odds, so I did the Pythagoreans on the back, and I'll show you those in just a second, but I did my even odds. Sine of a negative angle is equal to negative sine of the angle. Cosine of a negative angle is equal to just cosine of the angle, and tangent of a negative angle is equal to negative tangent of the angle. Of course, you can check out why that works from the unit circle. Cofunctions: sine of pi halves or sine of 90 minus theta is equal to the cosine of theta. Cosine of pi halves minus theta is equal to sine of theta. And tangent of pi halves minus theta is equal to cotangent of theta. Now, if I were here, I would show you on the unit circle why that works, but you can figure out if you have sine of 30 is always equal to cosine of 60. Cosine of 30 is always equal to sine of 60, and vice versa. Okay, you can check it out on the unit circle. Okay. Now on the back, you're ready. You might want to add to your reading. So on the back, I put my Pythagorean identities. Okay. So yeah, we know this one: sine squared plus cosine squared equals 1. And of course, that's right above me, isn't it? It's up there in pink. But there's variations of it that I think is important for today's lesson. So if I were to take this identity and bring over the cosine, then I'd have the same identity, but sine squared is equal to 1 minus cosine squared of theta. Okay, or another variation, if I were to take this identity and bring over the sine, I'd have cosine squared is equal to 1 minus sine squared. Okay, and we will use these, and it's nice to have these. So if you have your reading, you might want to add those. Same thing with tangent. You have your identity tangent squared plus 1 equals secant squared, and that's right above me also, but up in blue. Another variation of that is if you were to bring the tangent over, you'd have secant squared minus tangent squared equals 1. Or another variation, if you were to bring the 1 over, you'd have tangent squared is equal to secant squared minus 1. Okay? Finally, the third one is the cotangent, and 1 plus cotangent squared equals theta. I'm sorry, 1 plus cotangent squared of theta is equal to cosecant squared of theta. Or a variation of, if you bring the 1 over, you can have cotangent squared is equal to cosecant squared theta minus 1. Or another variation, if you bring the cotangent over, you'd have cosecant squared minus cotangent squared is equal to 1. And we will use these identities. So hopefully you have those in your notes, because we're going to need those. Now, let's look at the actual notes, okay? So, one of the things I'm going to do is I'm going to do all of these on a separate sheet of paper. There's just not enough room. It takes sometimes a lot of room to do these, and I write big, so I'm going to do them on a separate sheet of paper. You can try and do them on this. Some of them might not fit very well. So, here we go. We're doing trig identities. 5/10. Oh, by the way, it is my birthday today. Sorry, I'm missing you guys. Anyhow, here we go. So, to do this one, I'm going to do example 2 first, then example 3, and I'll come back to example 1. Example 1 is a little bit more difficult. So, I'm going to go through it slowly with you so you can see how this works. So, let's do example 1, or example 2, I'm sorry. Example 2. Tangent theta times cosecant theta, okay? Now, whenever I try and do these types of problems, what I try and do is get things into sines and cosines if I can. So if I can get into sines and cosines, things happen, hopefully. Okay, so what do I know about tangent? Well, I know that tangent is equal to sine over cosine. So I'm going to rewrite tangent as sine theta over cosine theta. And what do I know about cosecant? It's the same thing as 1 over sine. So I'm going to go times 1 over sine of theta. Now, at this point, it seems pretty obvious. We can simplify it. The sines cancel, and you're left with 1 over cosine theta, and that'll simplify into simply being a secant of theta. Okay, So we took something that was a little bit complex and simplified it all the way down. It's kind of like reducing fractions. That makes sense? So we're going to reduce trig identities to a simpler form. Okay? All right, let's look at example 3 next, because example 3 is easier than example 1. Okay? So we'll go ahead and slide this up for example 3. And again, I'm going to do it on a separate sheet of paper because I write big and I need lots of room. So I've got a cosine cubed theta plus a sine squared theta cosine of theta. Okay, so before I do this one, what I recognize is that I'm going to factor. Okay, now on the little side work, put a little side work over here. If I had, for instance, x cubed plus y squared x, just x's, right? Not sines and cosines, just plain old x's. Little side work. I'd realize that these two terms have an x in common. So I can take out an x out of both terms, and that leaves me with an x squared plus a y squared. Okay, and I want to use that factoring, but with my cosines here. So I'm looking at it. Both have a common cosine, so I'll take out a cosine theta. If I take out my cosine, then I'd be left with a cosine squared theta plus a sine squared theta. Okay, now to continue, cosine squared, sine squared. Oh, wait a minute, that looks familiar. So I look at my Pythagorean identities. Oh, wait a minute. Sine squared plus cosine squared, or cosine squared plus sine squared is equal to 1. So I'm going to make this expression 1. So, all right, cosine theta times 1. Okay, so I'm looking at my identity sheet. I found it right there, made it into 1. And then obviously cosine theta times 1 is just a cosine theta. Okay, that's the simplest form. Okay. So what does this mean? You're going to have to use your identity sheets. You're going to have to find identities. The trick is, if you see squares, look at your Pythagorean identities. Anytime you see squares, look to your Pythagorean identities. Okay? If you don't see squares, then try and change things into sines and cosines. Okay? All right. I'm going to turn my page and do example number 1 with you. Okay? Example 1. A little bit harder, believe it or not. So example 1 has got in here, let's see, I've got a cosine theta plus a tangent theta times a sine theta. Alright, so I told you we're going to try and change everything into sines and cosines. So I'm going to change my tangent. My tangent, the identity for tangent is sine over cosine. Okay, and then hopefully you can find that. That's why I highlighted tangent, sine over cosine. So I'm going to use that identity. So I'll go, alright, cosine theta plus sine theta over cosine theta times my sine of theta. Well, that didn't do me much good yet. I have to do some more work. So let me go ahead and simplify this. It's cosine of theta plus, sine times sine is sine squared. Let me make this sine over 1 just so you see the fraction come, okay? So I get sine times sine is a sine squared theta over a cosine theta. Now, all I did was I changed the tangent and sine over cosine, and all I did is I multiplied the sine times the sine to give me sine squared. Okay, put the square there, not on the outside. Okay, now cosine over 1, and I'm going to add these two fractions by getting a common denominator. So what I'm going to do is multiply this first fraction by, common denominator would have to be cosine, right? Need them both to have a cosine, by cosine theta over cosine theta. Okay, let's see what that does for me, alright? So when I get my common denominator, I will have a cosine squared theta over a cosine theta. Okay, that's these two, cosine times cosine, cosine squared, over cosine plus sine squared theta over a cosine theta. Okay, now, I recognize that I have a fraction, they have a common denominator, I can add them. Okay, so my common denominator between the two is cosine of theta. Now, my numerator, or the top, is going to be cosine squared theta plus sine squared theta. Hey, we just did that identity, didn't we? Didn't we just see that cosine squared plus sine squared, or sine squared plus cosine is equal to 1? So this is going to be a 1 over a cosine theta. And 1 over cosine, gosh, let's see, that's one of our identities too. We know that 1 over cosine is secant. So we write that as a secant of theta. Okay? Aren't these fun? Actually, I actually like these. I really do. Okay. All right, I'm going to take this away, and if you need it, I will have it on my desk. Okay. Let's turn the page, and let's do example 4. Okay. And again, I'm going to do it on this piece of paper because it takes a little bit of work. Okay. Example 4, which is a secant of theta minus a cosine of theta all over a sine of theta. Okay. Well, what am I going to do? Well, what I'm probably going to do is change the secant into its identity. Okay, I'm going to change secant. I look at my identity sheet, and I see that secant is equal to 1 over cosine. So I'll do that first. Change this to a 1 over a cosine theta minus a cosine theta all over a sine theta. Okay, so all I did is I changed secant into 1 over cosine. So I've got 1 over cosine minus my cosine over sine. Well, that seems like kind of a mess, but I see a fraction coming. So I'll make that cosine over 1. And again, just like I did on the previous example, I'm going to need a common denominator. Well, this has a cosine theta, and this does not. So I'm just going to take care of the top part of this compound fraction. So I'm going to multiply this by cosine theta over cosine theta right here. Because I'm going to just take care of the top part of this fraction, right? So let's see what I have for this top part. I'll have a 1 over cosine theta minus, well, that's cosine times cosine is a cosine squared theta. That's cosine times a cosine over my cosine. That's all over my sine theta, okay? Alright, now, let's continue with this fraction here, okay? This fraction now has a common denominator, okay? So let's check it out. So it has a common denominator of cosine. Slide over here. They both have, there's a common denominator of cosine of theta. And on top, I'll have a 1 minus a cosine squared theta. Okay, now that's all still all over a sine theta. Oh boy, it's looking complicated, isn't it? Well, let's see if we can do something with this. Well, whenever I see a square, I'm thinking I better take a look at my Pythagorean identities. Okay, I see a square, so I go to my Pythagorean identities. And I'm looking for, oh, here's 1 minus cosine squared right there. 1 minus cosine squared is equal to a sine squared. So let's change this expression to a sine squared. So let me scoot this whole thing down here, okay? So this becomes a sine squared theta over a cosine of theta over a sine theta. Now this thing's getting close to being done. It still looks bad, but remember, when we have a fraction divided by a fraction, okay, a fraction divided by a fraction, we invert and multiply, right? Just like good old-fashioned 6th grade math. So let's change this to a sine squared theta over cosine squared, or I'm sorry, cosine theta. So sine squared theta over cosine, this fraction, and then we're going to invert and multiply times invert and multiply 1 over sine theta. Hey, we're almost done. We really are close, okay? Now, this sine squared with this sine, okay? One of these will cancel all of that, okay? A sine for a sine. And let's see what we have left. So then what we'll have left is a sine left over here, because I only took 1 away, over a cosine. Oh, wait a minute, that's an identity also. Okay, sine squared over cosine squared. That's tangent, isn't it? Yeah. Tangent. I am recording. Come on through. That's a tangent theta. Okay. Let's look at the last one. I'm going to be gone today, so I record my lessons. Okay, the last one, example number 5. All right. And again, I'm going to do that on a separate sheet of paper. Example 5. All right, example 5. Looks like a fraction again. We're getting close. Example 5, almost done. I have a 1 plus sine theta over a cosine theta plus cosine theta over 1 plus sine theta. All right, we have a fraction. Anytime we have a fraction and we need to add our fraction, we need a common denominator. Okay, so then it's kind of like this. What does this denominator have that this one doesn't, and vice versa? So this has a cosine in the denominator. This one needs a cosine in the denominator. So I'm going to multiply by cosine theta over cosine theta. Okay? So I'm going to multiply this one by cosine over cosine because this one has a cosine. And over here, the second fraction has a 1 plus sine in the denominator. This fraction needs a 1 plus sine theta over 1 plus sine theta. Okay, there. So now we're going to have a common denominator. We really are. So let's make this easy. My common denominator really is both of these. It is a 1 plus sine theta cosine theta. Okay? Okay, that is my common denominator. Let's just write it down. What goes up on top? Well, let's FOIL. If I FOIL, I have a 1 plus, I'd have a sine theta plus another sine. Okay, I'll have a 1 sine plus another sine makes a 2 sine theta, and then a sine times a sine is a plus a sine squared theta. I'll do that again. I'm just foiling 1. I get a 1 sine. Remember my outside inside on my double smiley. 1 sine, another 1 sine makes a 2 sine, and then sine times sine makes sine squared. Okay. Over here we'll have plus a cosine squared theta. Okay. Now, hopefully you recognize something, and if you don't, this I'll help you out with it. But I see this right here. Okay, so I see, okay, sine squared plus cosine squared. Anytime I see a square, I'm thinking, okay, let's look at my Pythagorean identities. So what is sine squared plus cosine squared? Well, sine squared plus cosine squared is 1. So I'm going to change sine squared plus cosine squared into 1. So I'm going to rewrite this as a 1 plus a 2 sine theta plus 1, because the sine squared plus cosine squared equals 1, all over my 1 plus sine theta times my cosine theta. Okay, now, alright, hopefully you can see 1 plus 1 is 2. I'm actually going to add those two. My 1 and my 1 together make that 2. Or slide this up so you can see it. So I'm going to go 2 plus 2 sine theta all over 1 plus sine theta times a cosine theta. Now I'm getting close, okay? So then 2 plus 2 sine, I can common factor, and that's going to help me right here. So if I take out a common 2, it's going to get something here. So I can common factor out my 2. So take out my 2. If I take out a 2, I'll have a 1 plus a sine theta. Haha, I like that, because over a 1 plus a sine theta times a cosine theta. So all I did was this. Common factor out the 2. That's it. If I take out the 2, I'll have a 1 plus sine, and I'll still have it over my denominator. And then cancel, boom to, and then I'm left with 2 over cosine theta. Now we can fix that, because if it's over cosine, it just becomes a secant, because one of our cosine is a secant, so I'm going to change this whole answer to 2 secant theta. Alright, that is it. Are they easy? No, but you need to practice them. Of course, we've talked about practicing and not just sitting on your rear, because come test time and retake time, you don't know what's going on. So you absolutely need to do your homework, okay? I think we have enough smart people in here to be able to figure things out. I think you have a good math teacher here also to help figure it out. So you need to do these, okay? Page 542, 4 to 24 even. Put your phones away.